Alright, so we're going to start by talking about the real number system. This is section 1 of your notes. There are a lot of definitions at the beginning. The only one we're going to go through on here, though, are rational numbers. And rational numbers, one way to think of their definition is any number that can be written as a fraction, which includes integers, repeating decimals, and decimals that end. This integers, that's something that's in your book. You're going to have to read the definition of that. So some examples. -5. And that's because -5 can be written as -5/1. Now it's a fraction. And so it's a rational number. 3/5 is already written as a fraction. 0.45 repeating. This would be considered a repeating decimal. It is also a rational number. And then a decimal that ends means it's a decimal that has a definite ending point. It ends right here, does not go any farther. It's a rational number. So now, given this set, we're going to list which ones are each of these categories. So starting with natural numbers, these are your counting numbers. And so they're just, in our case, it's just going to be 7. Whole numbers are the natural numbers plus 0. So we'll have 0 and 7. Integers are the negative and positive natural numbers plus 0. So in our case, we'll have -2, 0, and 7. Rational numbers are what we had up just above. So this is going to be everything except that root 7. Notice with 1.5 in particular, this 1.5 can be written as 1.5, which is 3/2. So you can write that as a fraction. Irrational numbers are any numbers that are not rational. So all that's left is root 7. And then all of these are considered real numbers. Real numbers are all the rational and irrational numbers. Once again, the definition of all of these is in your textbook, and so you do need to be reading that as well. Alright, so now some inequalities. This first one, that is not equal to. An example, 5 is not equal to -5. They are not the same number. Next up, is less than. 6 is less than 10. Next up is greater than. An example would be 3 is greater than -5. The difference between these two is you always want to eat the larger number. Notice in this case it's open towards the larger number, and in this one is also the larger number. So when you read it across, we have 6 is less than 10 because 6 is less than 10. Here, 3 is greater than -5. So you always want to think of it as opening towards the larger number. The next one is less than or equal to. So this can be like 2 is less than or equal to 7. So 2 is less than 7, so we're okay. But also, we have the equal sign here. So 5 is less than or equal to 5. You can use it there as well. Same idea for is greater than or equal to. It works for the equal, or it can also be the greater than. This last one is approximately equal to. So this is going to be when you're rounding or close. For example, pi is approximately 1.415. We can use that approximation when dealing with it. Alright, so now, given our inequalities, do interval notation. And first off, for interval notation, we always start with our lower bound, or the lowest number, up to the upper bound, or the highest number we can have. And then we're either going to have parentheses or some sort of brackets. The parentheses are when it's not equal to. We're not going to actually get to that number. This isn't when it can equal. So in our case, if we look at x is less than or equal to -9, that means we want everything, if we drew a number line from -9, we want everything going this way. We want the numbers less than -9, meaning the highest number we can go is -9, the lowest is going to be -infinity, and so -infinity, we can't actually get that because it's not actually a number. However, because of this equal sign here, we do want to include 9, so we're going to have a bracket. Next up, looking at x is greater than -3. So if we have -3, we want everything greater than it. So that means we're going to go from -3 to infinity this time. Once again, we can't hit infinity, so it's an open parenthesis. But then also notice we just want strictly greater than, so we can't actually equal -3 either. So it'll be a parenthesis. Now, up, we're looking at absolute value. And one way to think about it is the distance that a number is from 0. Think about when you have distance, you cannot have negative numbers, because no matter which way you go, you always win somewhere. You're not going to go a negative distance. So first off, if we look at -20, that is still 20 units from 0. You still went 20. So our absolute value is 20. Next up, if we look at 5, from 0 to 5, we still went 5 units, so it's 5. This last one is a little bit tricky, but let's focus on just this one first. This is 12 units from 0. So the absolute value of -12 is 12. But then we still have this negative on the outside, so it becomes -12. And so this is all for section 1.1.